Hello and welcome. My name is Jonathan Ringer, here to talk about Ekapkgs. Originally, this was meant to be a talk for Planet Nix, but was told by the event organizers to not take it or not give the talk. I don't blame them. They were just trying to avoid the likely outcry of drama in the community, and they're trying to make their lives easier, so there's no hard feelings there. But I would still like to record this for kind of posterity and have kind of the vision that I have for Ekapkgs be kind of cemented in some type of narrative, especially like a video. There are a series of blog posts that have been going up, but they're all kind of smaller sections of this grand total holistic vision that I have, and I thought it would be good to kind of just expand upon why I'm going upon this endeavor just in general. And so with that, why even do this? Well, the thought of doing a Nixpkgs fork never really occurred to me until the drama of last year, and the first person that I could remember that recommended doing a fork was this individual called Samuel Dr. But the date here on April 25th is actually quite important. That is the day that I was suspended and removed as my release manager for the 2405 release. And then 2 days later was when Elko pretty much resigned from the foundation board and delegated a lot of his personal authority. And then 8 weeks later, I was banned permanently when trying to get my commitment back. And during that time, when I was banned from the community, I had quite a bit of time to kind of reflect and decompress on kind of just Nix in general. And then the idea about, hey, if I were to do a fork, I wouldn't want to do it in the way that Nixpkgs is doing it, because the way in which Nixpkgs does package curation pretty much relies very heavily on a lot of contributors to be able to do a huge amount of manual efforts to do things like infrastructure maintenance, review PRs, and a bunch of other stuff where it's actually very difficult to kind of maintain the beast. Even though Nixpkgs is kind of state of the art in terms of its size and freshness, it is still a far cry from what it could be in terms of really valuing contributors' time. So what is Ekapkgs? So Ekapkgs, I'm trying to solve several dimensions of issues here, but the main one is kind of trying to find a maximum in terms of maintainer, contributor, and consumer experience, and allowing for these things to kind of align, where making it easy to curate packages, maintain package repositories should then also go into allowing for things to be remedied quickly, and then the downstream consumer of those package sets should have a better experience because issues get solved in a much better timeline. And so going right into kind of the larger changes, I have many different changes that I would like to see, but the biggest of all would be splitting up the Nixpkgs monolith. Originally, when I was doing this, before it was called Ekapkgs, I called it the poly repo experiment, and there I was just doing kind of formulation and kind of proposals around what a Nixpkgs-like package repository would look like. And here, the main idea that came into my head is that, like, we need to get rid of this massive single source repository. Even though Nixpkgs in a way is revolutionary by having, 100,000 different package expressions co-located in a single repository, this size actually comes at a great cost. And mainly this cost comes with like rebuild count. So if I was a contributor and I wanted to update something like glibc, OpenSSL, curl, all of these packages would actually cause a standard env rebuild, at least for Linux. And then I have to kind of affect 100,000 different packages. And the reason why this is less than ideal is that then it's actually very hard to test these things, because testing 100,000 different builds means that essentially you need to expend the compute to build all of those things. And that's the thing, is that like you have a very small core set of maybe a few dozen packages, which largely invalidate the rest of the package builds. and then you just need to rebuild everything from scratch. To mitigate this, actually, upstream Nixpkgs has a process called staging, where everyone kind of stages their large breaking builds into a single branch, and then that branch is just periodically stabilized over time, called staging next, which was ratified in an RFC. But the staging next workflow has multiple facets of pain points, which I'll get into later. But the thing though is that you'll see this theme time and time again, is that to deal with a particular pain point of Nixpkgs, a workflow was set up. However, it generally causes compounding complexity in terms of maintainership, curation, and then kind of consumer expectations to all be misaligned. And it's actually quite difficult for us to remedy these issues. But by splitting up the package repositories, you can have something where it's corepkgs here is the most foundational one that I'm going to talk about. But corepkgs would be things like compilers, interpreters, foundational libraries like OpenSSL, curl, etc. Things that you would normally expect to have to build or deploy software is how I'm going to describe it. And it should be all the stuff that you would normally use to build. Yeah, so if you want development shells, or if you want to build single purpose kind of containers or something like that, corepkgs should kind of contain all that you really need. And you could also relate this to kind of the Arch package repository if you were to compare it to a different ecosystem. But even then, that's probably larger than what I'm actually going to be trying to communicate here. And then downstream of corepkgs, then we have all the other overlays. So we'd have language overlays like Python and Haskell and Node. And then downstream of those, we could have ecosystems. So Home Assistant, CUDA, Vim plugins, Emacs. And then at the very end of all of this, we'd have something like Ekapkgs, where all it really is doing is just tying together all of the other kind of language and ecosystem overlays, and probably being the backstop for other builds which are just too high in complexity for the other overlays. So things like web browsers or distributed file systems, where generally those dependency trees are very large and may not actually have all the dependency requisites needed to build in just single overlays. And and then how this would be offered up to individuals is that we would offer flake and non-flake entry points. And so then if you want to do the flake route, you can. If you want to do a non-flake route, then there will also be a kind of non-flake pinning, and that would use eval time fetchers to then retrieve the overlays so that there's no IFD. All right, and then the value proposition here is that now you can actually kind of optimize for a particular consumer. And by consumer here, I mean if I'm a user of Nix, I'm usually of one of two camps, which is either I really want to just build software and I want things to be, stable, building, available in the cache, fresh, and so freshness here is important for CVEs. Generally, if I just have up-to-date patches, then I kind of am heavily mitigated against CVE vulnerabilities. And then on the flip side of this, though, I could also be at the other end, where I'm kind of more of a end user of software. So think of someone like a desktop user, where I want things like Steam, or I want things like a web browser or something like that, where I really actually care about package availability, and I'm willing to sacrifice a little bit of kind of stability and freshness for just kind of having those things available at my fingertips. And that's the thing, is that this paradigm shift and kind of separating into two different concern domains allows us also to have different stability guarantees. And so I could see a world where corepkgs could separately have a year-long LTS release, and that would be really nice for a lot of use cases where a 6-month release with a 1-month transition window is actually fairly painful for a lot of small, medium, and large businesses, where like it's pretty tight tolerances. If you kind of mold your processes around the Nix-first releases, you can work through the 6-month windows with 1-month translation windows. But in general, though, it's less than ideal, especially if you have stuff where it kind of just languishes over time, and then like every so often you have to come back and revisit kind of that packaging pain, and it's not the best. The other benefit too is that, and I kind of touched upon this earlier, is that mainly we are getting rid of the staging workflow, and having just like one way that people contribute all contributions to core packages just eliminates a huge plethora of kind of issues. For those that have never contributed against staging and Nixpkgs, staging is particularly like infuriating to develop against, because let's say if I'm doing a bump to the default Python interpreter version, and then someone else also merges something into staging where then they break, let's say like NumPy or something, then like I may be testing against master initially, because pretty much everything except for the things that I'm changing are in the cache, and then like things seem to be good to me, and then I rebase onto staging. Congratulations, now a large swath of like Nixpkgs Python package set is no longer building. And that's the thing, is that like staging, effectively each staging PR comes to a point where people make this compromise of it's building well enough, and then we just merge it in. And sorry, not we. I'm no longer part of the Nixpkgs community. Nixpkgs will a Nixpkgs contributor will merge it in, saying like, it's tested enough, and then we'll just get around to this on staging next. But the thing though is that then it's like this contention for other contributors that are also trying to target staging. And then by just kind of not having this workflow at all, and we work now green to green, having your green to green kind of PRs just allows you to never really introduce downstream regressions. And I will hit upon later how we actually enforce that when we have dedicated tooling. But it's not like we can really get away from this quote-unquote staging workflow altogether. The one thing that does get put in its place, though, is essentially bumping pins. So then in each downstream repository, like the Python ecosystem Haskell node, effectively there will be like a periodic desire for us to update the core packages pin and then have a stabilization effort there. One thing I will say though is that this does still have a very large net benefit, mainly in the case that you can do staging, or you can do this pin stabilization separately from doing package curation stabilizations. And so like what I mean by this is that like Python packages, there's a script that you can run that then tries to force update all of the packages, and that would be kind of like stabilizing a Python package update. But that can be done separately from like a staging next. And where I'm trying to allude to here is that even if you were in Nixpkgs and you were doing a Python update run, you would still need to effectively target something like staging or staging next for your PR, because going directly to master is kind of not acceptable. And now that these overlays are just loosely coupled, they effectively can have their own timeline determinations for when they want to do these stabilization efforts. And that in itself is highly beneficial. The other thing that's beneficial here too is that when you're doing stabilization efforts, you have better control over what was green before your attempt and then what was green after. And then I'll hit upon this later, but the idea here is that there will be better kind of granularity on when to mark things broken if they need to be broken, or fix them when they do get broken initially. Okay. And then in another dimension, this is also very nice because now commit access isn't kind of an all or nothing in Nixpkgs. For example, if you get commit access in Nixpkgs, now you can merge kind of any PR regardless of ecosystem. So it could be like C, C++, Python, Node, Haskell, Emacs, Vim. Like there's all these like different varying ecosystems within Nixpkgs, and you getting commit access essentially opens the door for you to do anything consequential in those domains. And that has always been kind of a point of contention for getting commit access, which is that like, hey, if you do get commit access, you should know like nix-modules, you should know functions, you should know the Nix programming language fairly well, you should know like the like 2 or 3 language ecosystems, and like there's pretty much this ever-rising bar, because effectively once someone gets commit access, they are just entrusted with a huge amount of responsibility. Whereas if you split up the poly repos, now you have a finer granularity of those like specific domains, and so it's easier to be like, hey, you really like Python, you have a good amount of knowledge for the intersection of Nix and Python. Like I feel fine giving you commit access to be able to kind of curate just the Python package set. Like you don't have to be doing stuff in core, you don't have to be doing stuff in Nixlib. You can be kind of just like introduced to just a domain that you're actually very good at. Okay, and then the other thing that's trying to be tackled here too is that checkouts of individual repositories can be significantly smaller. This should be remedied with the lazy tree additions in later Flake evaluations, but the issue right now that I see as just a user of Nixpkgs and Flakes is that each time someone has their own reference of Nixpkgs, essentially it's its own checkout in the Nix store, and each one of these checkouts is like 400 plus megabytes. And that is like a fairly large amount of cruft to be having around. And although this can be mitigated with things like the auto-optimized store and various other mechanisms, it's still less than ideal. And yeah, moving it to where you can just kind of selectively opt into smaller individual repositories, overall the usage should be a lot smaller, especially with things like lib, where that's going to be very stable over time. You don't need to necessarily have varying small deltas, but including like a large majority of the source space to just be like reallocated each time. So that's another thing. This is like very secondary. Usually storage is quite cheap, but you know, if you have 10,000 different checkouts of Nixpkgs, it does add up over time. In addition to this, and I kind of mentioned this earlier with like the staging workflow, but like the lower rebuild blast radius that I'm going to call it, like if I were to propose a PR in a given repository, me just not affecting as many things has a huge benefit to kind of the CI/CD infrastructure. I no longer really need to build up to potentially 100,000 different things that have been potentially affected. I can, you know, each one of these things should be like 10,000 or less packages per repo, and so that's kind of like the maximum cap for any type of change that is being proposed. And this just kind of helps at every level of the organization to mitigate large rebuild counts. And I mentioned this earlier, but with the stability guarantee, I would really like to see corepkgs eventually adopting a 1 year long stable release. And so then people that are small to medium businesses that don't need things like Dwarf Fortress available in their package set, they can kind of opt into having just like compilers and fundamental libraries being available. And they should be able to get pretty far with that. And the year-long stable release really gives a lot more of a kind of slippage window for them to schedule their updates. All right. The negatives, of course, like this isn't just like, you know, going to be fixing every problem in the world, but one of the things that will probably be most apparent though is that if you do need to do changes that cross multiple repositories, this will be now significantly more painful. So think of something like protobuf, where you have native bindings to C and C++, but then you also have Java, Node, Python, etc. bindings, where if you do need to touch these kind of language bindings in the downstream overlays, is now significantly harder to do so. I will say though that there is another proposal that I have later on, which should hopefully mitigate this a bit around multiple versions. But I'll get around to that one that is more relevant. And then just curating these repositories though, like if you also want to do something like a git bisect, then your commands will probably be quite a bit more gnarly, and that's just going to be an unfortunate consequence. But I feel like I would gladly eat this pain if like corepkgs was incredibly stable. Then a lot of these potentially like large impactful changes should be less concerning, and like the level of abstraction and stability guarantees can vastly kind of mitigate potential just like constant flux. Like hopefully the packaging creation is like loosely coupled enough where we don't have to worry about everything having to be super coherent on a per commit basis. And then, of course, if you've ever contributed to Nixpkgs, your next question is likely to be, how do you go about managing to review PRs? Congratulations, you now just have like 12 repositories now to review PRs in. This doesn't sound necessarily super beneficial compared to the norm on Nixpkgs, which is just like 100 PRs per hour in a single repository. You effectively have the same amount of mess, you just moved into 12 smaller piles. And that kind of take is correct, but the idea here with Ekapkgs is that we can actually use specialized and very focused tooling to mitigate a lot of this. And so in particular, EkaCI is the ongoing and current active development effort going on in the Ekapkgs space right now. Pretty much Ekapkgs is on pause until this is in a ready state. But the idea here is that I would really like to have a review portal for all PRs. And this first started actually with the idea that I had back when I was a release manager for Nixpkgs back in 2020. I really wanted this thing where it's like if I had 15 minutes a day, how could I best optimize that time usage for reviewing PRs? And the thing that really irritated me about reviewing PRs in Nixpkgs is that I would go into like the PRs tab, and then I would, just open up a bunch of tabs, and then I would just click through them as I could. And then of course, it's like the normal run through. It's like scan for me to comment on anything. If I don't need to comment on anything, now I need to actually review for regressions. Technically, I didn't need to review for regressions, but it always feels really bad if you're a committer and you are like, okay, the CI gates were green, my review passed the sniff test, and so I merged the thing, but I actually broke downstream consumers because maybe they did a break and change in a minor release, or maybe I don't know. Let's just say that like software is non-trivially complex, and you really want more guarantees. And so during COVID, I actually built a pretty beefy build server where then I could actually launch what's called Nixpkgs review commands. And these commands were really beneficial in terms of like it would build everything downstream. Unfortunately, it didn't answer were these things existing regressions or did they actually fix builds. It was just kind of up to me to try to like run the builds individually, and then I could determine whether or not things were like newly failing or newly succeeding. But it still gave me a little bit more of a green light. And in addition to RFC 119, which was the formalization of the pass-through.test convention, then we had a way for us to kind of at least have like, this is roughly good enough. And then if it wasn't good enough, then we could just add the thing that may be highly sensitive to these updates in the pass-through.test. And so like incrementally, we kind of converge to a better state. But what I would really like for Ekapkgs is actually to be kind of able to like determine the strictness of build failures per repository. And what I mean by that is like for corepkgs, pretty much any failure is a critical failure. A PR should not be going in where it causes regressions, because for a package to be in corepkgs, it is considered to be critical, and so then it's unacceptable for you to introduce regressions. I'd much rather push off on your PR if you were to cause builds to fail. And then the other contract there too is that then downstream overlays expect everything in corepkgs to be building. So now you just kind of cause pain in downstream repositories, which is what I would consider unacceptable. But like for the other overlays though, maybe I would want to relax that strictness. And so then in something like Python packages or Node, then maybe like as long as something's not newly failing, then it still would get the green light. And for like Ekapkgs, then it's going to be probably closer to Nixpkgs, which is like as long as the thing in question that you're changing still builds, then maybe we're fine with it. But that's the thing though, is that like I would really like to have different kind of levers to give kind of different guarantees that are more appropriate for kind of the domain that I'm working in. And the other thing that I would really like to see too is like reasons to say no propagated up earlier. And so if I'm a author of a PR, what I would also really like to see is like a PR gate showing me that, hey, here is a new failure, or here's a failure because of your changes, and now you should actually remedy these things. And then I could actually go to that gate and see what it is. And so then once this is kind of formalized and all said and done, ideally what would happen is that if I were to open up a PR that affects one package plus 2 downstream packages, I would see 3 gates being launched for x86 Linux with each one of those attributes, and then each one of those attributes would be built, and I would be able to get the kind of build status of those things. If I did cause a regression, then I'd be alerted immediately. The other thing that this does too is if I do need to mark something as broken, that is also an option here, then I can actually do that at a more appropriate time when I'm doing the PR. One of the things that I had issues with when I was a release manager is that after you do a zero Hydra failures, one of the steps that you're supposed to do is go through every single failing build from the Hydra evaluation and mark them as broken. The issue with this is twofold. One of which is that it's actually like just like a really poor workflow in terms of like we just didn't get around to this, and so now we're just going to mark it as broken, and then now you get eval failure. And so then that's particularly not nice, because then if someone wants to fix it, then they have to like pretty much undo your broken equals true and then try to actually determine the failing build. So that's like pain point number 1. Pain point number 2 is that as a release manager, effectively you're 2 steps removed from why that actually began failing in the first place. And so all you can really do at the time is just mark broken equals true with really no additional context, unless you love burning your time, in which case then you can do a bunch of evaluation and attempted builds, look through the logs, and then kind of try to correlate as to why that build failure is now manifesting. Was it a dependency update, or was it like a botched update, or I don't know. Like, how do these things get to a failing build? Actually, I would do the argument that earlier I made the reference to the staging next workflow. That is usually how I see most regressions get introduced, is that you're doing these large impactful changes. Once you get into this long tail of, small failing builds, then you throw your hands up and you're like, well, I spent a few hours, fixed it as much as I could, and I'm fine with that. And that's the thing, is that it's generally there's just like accumulated tech debt. Someone eventually kind of needs to eat it, but not in like the strictest sense. And what I would like to see for Ekapkgs is that technical debt kind of being patted down more consistently when those regressions are introduced. And another way to kind of phrase what EkaCI should be is kind of like a Hydra 2.0, where it can do these large evaluations. It can dedupe with previous evaluations and build attempts, and so then it should only need to attempt to build things that it never has attempted to build before. So we make very good usage of kind of compute and storage resources. And then also too, like ofborg in upstream Nixpkgs is essentially just determines that like you didn't break the evaluation and your packaging question builds. I would like to see that too. And then kind of with the Nixpkgs review tools, what I would really like to see with the EkaCI is being able to run commands where then you can replicate a shell for a particular build. And so then if you do want to investigate why a build is failing, then it should be relatively easy to reproduce that failure. Hydra also has a similar kind of tool as well. Okay. And taking a step back from kind of the technical and more the social aspect, is that one of the other things that I would really like to encourage with Ekapkgs is actually process improvement. And so if you worked with the upstream process improvement process, they have one called the RFC, request for comments. But the thing that I find lacking in this process is that it's actually like a very non-trivial amount of work to sign up for. So, for example, if I wanted to suggest, like, hey, I really am annoyed at stale fixed output derivations, I would really like to see a change where version and or ref info gets imprinted into the derivation name, so that we always have a unique derivation name, so it always attempts to build, and therefore largely avoids stale fixed output derivations. I need to go through what I would consider an unnecessary number of hoops. I need to draft up the RFC, which actually that's just like you should be explaining the problem in your solution if you are proposing a solution. So I still agree with that. But then pretty much everything downstream of that I pretty much disagree with. And so in particular, it would be trying to rope in 3 other shepherds. That is usually painful. Then you generally need to put a post on Discourse, and so that people are aware of it. And then now it's opened up for the public to then comment on that. And then the problem with the public commenting on it, actually, I'm a big supporter of kind of diverse viewpoints. So like I actually want a lot of feedback to things that I am proposing, especially if there's a lot of unknowns. But the issue there is that the RFC process essentially can be prolonged indefinitely by chatter. And it's like only if there's no chatter and things kind of questionably seem stable that an RFC actually gets merged. And so then that's the thing that really kills me, is that like when you want to do an RFC in the Nixpkgs NixOS ecosystem, what you're really signing up for is like a multi-month, likely year or longer endeavor with like very low chance of actual success. And then you also need to rope in 3 other suckers to also kind of endure that pain with you and eat that glass. And then maybe you can get to the other side of it. And what I would really like to see for the Ekapkgs ecosystem is really more or less have it where the RFC steering committee is replaced with a process proposal committee, where the process proposal committee effectively acts as your shepherds. And so then these individuals have the like enough technical know-how to actually give you actionable feedback, whether or not your proposal aligns with project goals and is doable, feasible, able to be achieved on a reasonable timeline. All the smart things, specific, measurable, attainable, realistic, and timely. And yeah, and that's the thing, is that like I really would like it where the committee is actually able to get these proposals into a state where they can be acted upon, instead of like this constant dubious state of I'm not actually sure whether or not I'm making forward progress. So I don't want to invest a large amount of time to trying to see my goal come to fruition. The other thing that I would really like to see in the Ekapkgs ecosystem is kind of consolidation of documentation. In particular, what I would really like for is the onboarding story that is like universal and unambiguous. In particular, I get great inspiration for the wrestling book. I think it's a great resource in terms of it doesn't assume any technical knowledge when you first are introduced to it, but it does a good kind of structured layout of different programming paradigms and concepts that then actually enable you to use Rust at the end of it. At least the 20% of Rust that you use 80% of the time should be fairly familiar once you're done with that. And I would really like to see that in a Nix format as well, where once you're done reading this thing over the course of a day or a few days, depending on your background and whether or not you're adept at functional programming and the concepts, but like eventually there should be a time where when you finish the book, you should be like maybe not comfortable, but at least you have a good index as to, oh yeah, this thing looks familiar. Let me try to find that thing. And instead of like the nix, it feels to me, especially watching a lot of people kind of try to pick up nix, is that like the reference documentation is there, but the people don't really know what to even look for. The traditional thing that was within the Nix ecosystem was something called Nixpkgs, and I feel like Nixpkgs is a good resource, but I would kind of describe Nixpkgs as a, if I were to try to find a resource to learn how to drive a car, Nixpkgs would essentially explain how an internal combustion engine works. Like, it goes into a lot of detail about how standard div make derivation works, and a lot of the details where it's like, yes, this is all good, but it's kind of at a lower level of abstraction than I would really like at the time, which is like, I just want to be able to use Nix. I don't necessarily need to know how standard div make derivation implementation works. In addition to this, I'm usually a very big fan of video series, as you can tell, because I'm re-recording this right now. But I feel like the narrative format is really good for kind of getting more of an insight into kind of the why, and at least for how my brain works, is that generally if I'm able to kind of associate relationships and or reasoning, like causation, or like causality or correlation, then generally I have like a better way of kind of structuring the information in my head, and I seem to be able to retain it better. At the very least, if I know the intuition as to why something is the way it is, then it's much easier for me to reason about where I should go next. And yeah. And I would also be remiss to not cover governance here as well, especially being banned in upstream Nixpkgs spaces. The other thing that I would really like to see is that there's kind of a bringing back to just kind of treating people as human beings. In particular, the Eka ecosystem has adopted something called a code of ethics, which essentially just fixates on kind of respect, autonomy, integrity, curiosity, and pragmatism. And so this is more just like everyone should kind of be a self-governing individual. I'm not trying to speak for the others, but I feel like they would probably share this viewpoint in general as well, is that we really just want it where free and open source software is really about hacking and collaborating with others, and that you should just be able to treat them, even if they have differing viewpoints or backgrounds or skin, ethnicity, religion, that like it should be a common space. Everyone here kind of comes because of their own volunteer or free will, and so you have something in common, and generally it would be nice for us to kind of consolidate around a shared vision rather than criticize each other for differing viewpoints and or worldly situations. Yeah, and I think in general though, like, diverse perspectives is usually a benefit because not everyone is perfect, and so then being able to pick up on, different ways to do things. Generally, it can be like a revelation sometimes if someone can find a new path that is significantly easier and likely would have never manifested in the perspective that you were taking. All right. So now I covered kind of like the large changes, the structural changes to kind of how the repositories would be laid out, the tooling, in particular EkaCI, to then optimize the ability for us to kind of review PRs, and then governance and documentation. But there's also just like a long list of kind of smaller changes that I would also really like to see get ratified into a Nixpkgs set as well. Some of these might be applicable to Nixpkgs and like a RFC, but I'm also banned there, so that's not relevant anymore. But this is what I like to see. So this is largely from RFC 171, but I called it at the time trying to avoid still fixed output derivations. I don't know if anyone's ever come across this, where it's like you bump a version thing and then you forget to invalidate the hash. You go to build it, you're like, oh, the thing builds, the derivation name is updated. However, when I do -- version, it gives me the old version. What is going on here? Well, what is going on is that effectively Nix identifies a fixed output derivation by its derivation name and the output hash. And so then if you update a version in a package expression, you're not actually changing the derivation name because they all default to just the name source. And then you didn't update the hash. And so then nothing really invalidated the previous stale fixed output derivation. And that is just a very common pain point. When I did the first initial changes of this like 3 years ago, I found 50 or so packages that had stale fixed output derivations. A few of them had stale ones for just dumb GitHub retrieval reasons, but the majority of them, though, were actually like someone just forgot to bump this in the previous PR. And that's the thing that I would like to change, is that it's a bad user experience. We should fix this. There was some attempts to do a more principled change in the actual Nix CLI to do this. However, it was a very easy change to do in the Nixpkgs source code, and for all intents and purposes, it doesn't really matter. Like the worst case scenario is effectively the build gets reattempted. We've come to the same fixed output derivation. The cache is all content addressable, so that doesn't actually change. Effectively, what you did is just like one fetch. You reasserted that the fixed output derivation was still true, and then you moved on with your life. And so that's the one thing that just irritated me, is that this didn't actually cost a lot in storage. It would be like one staging next iteration of kind of fixed output derivation builds. But other than that, like there was no good reason to reject this other than I had to find 3 other people to be shepherds. I found 2, and then it kind of petered out, and blah blah. And then when I got banned, essentially no one really wanted to take up the reins of that amount of pain. Anyway, so this is just one of many. All right, next one. Align file paths with attribute paths. This is one thing that always has killed me when I was in upstream Nixpkgs. Like, oh my god, which file do I actually need to find to remedy this thing? And so then it's just like the way that you would kind of find the attribute should then reflect where the file path is. And so if something is in Python packages, then it should be something like along the lines of Python packages package. If you're at the top level scope like GKA3, then it should be somewhere like packages GTK. Like I shouldn't need to know that this one's in libraries, this one's in Python modules, this one's in server, this one's in tools, this one's in application, blah, 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 blah. One thing that Upstream did do is a adoption of this by name convention. And so then now there's just a kind of, it's not technically a flat space. It's sharded by the first 2 characters of the software name. But that is kind of a normalization, but it also doesn't align with the attribute path. It's kind of odd that it's like packages by name, like CMake would be cm/cmake/package.nix. The other thing that I'm not a big fan here too is always calling it package.nix, because it could be like a function. I don't know, whatever. Okay, this is kind of the biggest thing for me though, is from like a consumer experience standpoint, is kind of normalizing how all the mini variant packages get exposed. Effectively in Nixpkgs, all of these things just get aliased at the top level packages scope, which is quite annoying. And it's also highly inconsistent. And so like, for example, here I have ffmpeg4 with no underscore, and then I have openssl underscore 3 underscore 3. The node packages is node.js-16 underscore x, which means just like the 16 is the major version and then x is the minor version. What I would like for instead is actually just have us to specify these things as pass-through attributes on a quote-unquote like package, like a more meta version of a package. So like a package that is kind of enumerated over multiple versions. And so like you have ffmpeg.v4, and the like ffmpeg here would actually give you a derivation for the default version. It's just that if you want to, you can opt in to a more specific variant if needed. And how this actually works is that we have a make mini variant function, which allows you to pass like a generic.nix, a version attribute set, deprecations that you could have, aliases, And then the default projection is just given the attribute set of the versions, which one would you actually want to serve up as the default. And so that's just kind of like how FFmpeg resolves to the default version. But like here, the nice thing about this has multiple effects. Number one, we're no longer polluting the package scope with all of these aliases, and so now we're actually kind of internalizing all of these different versions into the quote-unquote package directory, which is really nice actually. And so then if you were to do something like bump a default version for FFmpeg, then that would just be located in the default.nix. If you're bumping a version, then that would just be in the version attr set. And the thing here is that you get kind of two attribute sets when you're doing these kind of generic make many versions. And so like on the right here, you can see that the first attribute set is all of these things that are kind of generic over any type of package build. And so things like with docs, and like package older, package at least, package between. And so then if you want to do comparisons of like, hey, if I'm before this version, I actually need these dependencies, then you can do so. And then the second attribute set would just be the dependencies. And so this would actually be kind of aligned with what normal Nixpkgs expectations are, is that then the inputs to a derivation are actually passed by function inputs. The other thing that this is kind of nice about too is that now toggles no longer get polluted with the dependencies that you call a package expression with. And so the example that I mentioned earlier was like with docs, but like, you know, if you're doing CMake and you want the minimal version, or you're doing Python, you want the minimal version. Now you do it where it's like not the same attribute set. And this actually has bitten me in the past too, where people will make toggles with package names like static, question mark, false. And then the problem though is that eventually someone is going to introduce a package called static, and now you are trying to see whether or not that boolean, which is actually derivation, is able to satisfy your predicate. And then you get some evaluation error now because someone somewhere introduced a package of a name that matched, or like that conflicted with a toggle that you named. And yeah, it's just annoying where like now we have the toggles as a completely separate thing from the actual dependencies that are being passed. And so like that's a nice separation of concern there too. And then also for things that have highly coupled information. So like here it's like version and hash, but you could also have like version, source hash, and like vendor hash for build Go module, or you could have cargo hash for build Rust package, where these things are like generally going to have to be invariant. You need to ensure that they are not invariant with each other. So like you need to update all three of them. And that's the other thing that's nice about this workflow as well. So like take something like OpenCV, where I think it has to do like 4 repository pulls. Now you could actually iterate like the OpenCV version and the other 3 hashes for the other contribs, and something else. And so like you could kind of just list all 3 of those things in like a very nice minimal attribute set in the versions attribute set. And then that just gets passed in. Anyway, the thing here is that it's like now there's like it's a little bit of a boilerplate, but out of the boilerplate is that now the things that have these concerns are actually separated into their own individual files. And it's easier for me to kind of like think about a FFmpeg over many versions. Yeah, so like this is useful, especially for like pinning. So like let's say if I'm going to consume FFmpeg, it's actually quite annoying for me to just say like FFmpeg as my dependency, and then I have the option in like all packages.nix to then say, oh, FFmpeg equals FFmpeg 4 or 6 or 8. Or I have the option of in my package.nix to say FFmpeg underscore 8, which is probably the preferred way, and then that works with like the callPackage by name convention. But it's like the thing though is it's like they're not uniform, which is very annoying, but having only one attribute at the actual package scope level now makes it so that people are kind of forced to do that paradigm. The other thing that this is nice too is that with the make mini variant as well is that now you can, let's say you are FFmpeg and you need to link against different versions of OpenSSL, let's say, then you could just bring in OpenSSL as a input, and then depending on your version, you can actually then dereference a individual version that is appropriate for that major version. Yeah, and this could be a little bit more of a maintenance burden, mostly just because your generic .nix package expression, it's a little bit more complicated, or is it complex? Complex, because of the kind of prospect of I have to reason about this thing over many versions. But on the flip side, though, is that now if you want to pin to new versions or old versions of a given package, now it should be actually quite a bit easier to do so. Okay, yeah, I do mention it later on. So later on, then I can do override variant, and then that override variant then allows me to introduce new things to that first attribute set that I mentioned earlier, and then it can reapply the dependencies immediately after that. And so what would normally be a version and source change, on the left-hand side, would actually now just be a version and hash change. But yeah, I mentioned earlier that not having to have all these aliases at the package scope helps to declutter these things significantly. The other thing too is that then also this compounds with aliases and deprecations. Now those get moved into the package scope as well. They get moved into the scope of the individual package out of the actual package scopes. Very confusingly worded, excuse me. Overriding for packages, yeah, I hit on this earlier. Vendor hash, cargo hash, other things that need to be kind of communicated along with a given version can all be done in one fell swoop. The other thing that this alleviates you to a bit is the awkward issue around override adders and different make derivation helpers. And so if you use something like override Python adders, you actually need if you use something like build Python package, generally you need to actually use the override Python adders, which then kind of applies the attributes to what got passed into build Python package. Because if you just do override adders, it actually just affects what got passed into standard env make derivation, and that's actually a different mapping of adders. The drawbacks here, and I kind of hit upon these a little bit, is that the make derivation helpers, now you can have two different structures for individual packages, and so it's not immediately obvious whether or not, let's say, something like curl actually uses make mini variant. Maybe it's still the old path, and now I had to make the determination. There is a pass-through variance which should only exist on the make mini variant packages, but that's not a guarantee. The other thing too is that, let's say I did actually want to call a package and then do an override OpenSSL equals something else, but then they dereference it in their package expression to a specific version. Now there's kind of a bit of a invariance there because they can kind of opt into a more specific version, and then we could mitigate this by doing something like what I recommended here, which is the OpenSSL v34 force, where it's kind of just regardless of what you now dereference, you're actually just going to get 3.4, but now it's going to be you're switching awkwardness at either callee or caller level, and there's not a good way around that. One little kind of quality of life thing that I would really like to see in a Nixpkgs repository is a call package, but it doesn't add an override or override derivation. So this is what I call autoCall. And so for something like the make mini variants, where I'm actually just wanting to pass it some arguments so I get a partially applied function, but I don't really care to override the arguments to that initial call, then this would be a good use case where let's say I just wanted to pass some arguments and then get back an attribute set of derivations, or wanted to pass some stuff so I get back a function. I really don't want override and override derivation there. They kind of are the wrong tool that gets exposed there. But they do get exposed because callPackages is just so darn convenient that everyone and their mother uses it. And it's kind of just an unfortunate thing where there's not a kind of slimmer version of callPackage. Yeah, and so then like in general, this would be used to just call things like functions and attribute sets. The other thing too is that like you could also do too where it's like, oh, here's my scripts, and then you call something that returns back an attribute set of your packages that you would want in your user environment. And then if you were to do like environment dot system packages equals attr values of that thing, now you have two functions in there, so you actually get evaluation error. And it's very surprising for people that it's like, why am I getting this this value is not a derivation error there. And it's just like, oh, you actually have it where you're doing callPackage is adding these two different functions. And anyway, it's not obvious. It's a bit of a foot gun. Overlays easy to apply at the package scope levels, and so this is kind of actually a requirement for Ekapkgs because we're breaking out a lot of these language ecosystems at the package scope level. So like for example, in corepkgs we would bootstrap something like python.packages or haskell.packages, but we don't actually kind of fulfill them in any meaningful context. So what we would actually like to do in the downstream overlays where you're doing a lot of this package curation is be able to kind of really fixate on those individual overlays and apply your additions to that in kind of like a very seamless fashion. And in particular, what I am recommending here for Ekapkgs is that we have it where the there's a little bit of a module evaluation for packages, pkgs, like the package scope, and that fixed point logic could receive other things than what it currently is. Currently right now it's like allowing free, what else is in there? CUDA support, check meta, a few other things where like these are they're pretty limited in scope. And what I would really like to see is that kind of gets opened up. Also too, if you have something like Home Assistant and things where it's like these may not even exist in corepkgs, I would like for other downstream overlays to also be able to expose their own config options. And so then yeah, I guess it's kind of just like, yeah, I would like to open the door to more complexity, but as long as it's like a constrained view complexity, I feel like it would be really empowering for individuals. The other thing that this would be kind of really nice for as well is that if you have whole other ecosystems, let's say like proprietary compilers or tool chains or like FPGA tooling, or what would be another one? CUDA with like, and you want to pass like a CUDA compat version. Like all these things where it's like, there are use cases where they would benefit from something like this, and I would just like to see that. And then the whole kind of one of the main core tenets of Ekapkgs is that you're kind of able to be freely extended by others beyond use cases that you originally thought of. Okay, and now to get into some of my kind of crazy ideas. Fair warning, like a lot of these are just like maybe half-baked. I think they're a good idea and I would like to investigate them more, but they're not necessarily going to manifest themselves anytime soon. The first of which is just simplifying cross-compilation terms. This is just like a really common pain point that I see a lot of people stumble with, is like, what's a build input? What's the difference between that and native build input? And just having more ergonomic names, I feel like would just go a long way. For those that don't have context as to why they're just called build inputs in general, is that if you are coming from the perspective that you're running the Nix CLI tool and you want to run a sandbox build of software, what would you call the inputs to the sandbox build? Well, build inputs. So like build inputs was like the OG original term for a lot of these things, where they would just manifest themselves inside of the sandbox. Then later on with the cross compilation, then we got the term native build inputs, but native here just means like it's of the build platform, which is also really confusing because build here is also a term. So it's like the actual build inputs. Anyway, so like what I would like to see is like native build inputs get mapped to commands. Like, oh, okay, these are things that are going to be on my path that I can run, or they are like shell completion stuff. But like build inputs now could also just be libraries because they're going to be for the target system. Hooks, just because like they don't really fit into commands that well, but they're a nice little lever for us when we're doing builds. In addition, like this would also pertain to the propagated variants of everything as well. So like propagated build inputs, propagated native build inputs, etc. You would see like propagated commands, propagated libraries, propagated hooks. Okay. And then also just simplify cross compilation. If you, I don't know why you would, but if you have taken a look at cross compilation in Nixpkgs, it does work. It works relatively well, but it has a few pain points. One of which is like a lot of package scopes actually don't have spliced package scopes, and so then they don't support cross compilation. But everything at the top level packages does, and Xorg and a few others that specifically opt into it, like Python. But it's not the norm. In general, most people will just use the lib.makescope helper, which that's not spliced. So there's a separate one called lib.makesplice-scope, which actually does that for you. The other thing too is that if you look at how these splices actually work underneath the covers, and so here's a little example, is like if I'm going from x86 64 Linux into ARM, then if I look at the spliced packages, which is what callPackage will call you with. So like if I got CMake, I actually get like a CMake package, but the normal CMake here would return back. Actually, I'm not even sure what it would return. I'm assuming it would be for the ARM variant, but how you get the divergent behavior of if I list CMake in my native build inputs versus my build inputs, and I get a different variant of CMake. This is actually how it works. So this is where the indirection gets manifested, and what it's actually able to do is do like, for this native build input, take the drv._splice.buildhost or drv. And so then for CMake, it would get the kind of one for x86 64 Linux. But if I put CMake into my build inputs, then it would get the host target variant, which is for the ARM target. And so that's how you get kind of the divergent behavior there. What I would like to see instead is that that double_splice whatever. I would just like for the default package set to just give you always a splice variant, and then that splice variant to give you a for build or for target thing. So you don't constantly need to do like protobuf.__splice.build host or protobuf. If you always really wanted to call the host version, oh my god, these terms are very confusing. The variant for the build platform so that you could actually run something like protoC. Jesus. Okay. The other thing that I'd really like to see too is something called pkgsModules. But generally, when you have it where you are exposing a flake, sometimes you want to expose like an overlay and maybe a config option like allow on free equals true or something else where it's like I actually really need to expose multiple things now, especially with how Ekapkgs is split up, and I would prefer for people to actually target different individual package scopes. What comes out of this is that like you actually need to potentially, let's say like you are just packaging a Python package, you probably are, packaging your Python thing so that it exists in all interpreters. And so then now you have a Python overlay, but then also too at the packages scope, you would really like to re-export kind of the script. And so then you would have some way to do like two Python application, my thing. And so you actually have like two different overlays and you want them both to be communicated. Well, now it's like, you could do that for any ecosystem. Maybe I have a Node, Haskell, maybe I have a Vim plugin, maybe I have a Home Assistant thing that I want to communicate. And so like, now you have like a dozen or so overlays that you may or may not want to communicate. Being able to kind of just normalize all this into a single packages module thing, and then kind of exporting it is really nice. And so if you just import like Ekapkgs, instead of doing like overlays dot blah equals here's a big list, and for all these other ones, instead you just have all of your modules enumerated in a rough fashion that makes sense. And yeah, I feel like that would be nice. In addition to this too, is that instead of being like upstream Nixpkgs, which is like, I don't know why, but like pretty anti-Flake in general, just kind of accept that that is a use case for people and just make it easy for them if they do want to make that use case. And so like here in particular, I just want to provide like a corepkgs.mkFlake in which you can consume all of your packages modules. It will apply all your overlays. It will give you fixed point packages. And then also too, it will make it so that you have it where when you are kind of selecting the outputs for your Flake, that they are relatively ergonomic to do so. So like, for example, here I have packages equals, and you're past a pkgs, so like the top level packages scope, and then you can actually just select what the package that you added was. And the other thing that is nice about this too is that because you're using overlays, now you actually kind of fuse dependency trees, and so you can kind of work nicely with other packages. You do lose a little bit on like the reproducibility aspect, but like I said earlier, one of the benefits of having a super stable core packages is that that should likely be a foundational pillar for you kind of to kind of build all other software with. And so you really shouldn't question you should always question things. You shouldn't have to question whether or not the stuff coming from core is of a particular quality and or like things are available. It should be relatively stable over a long period of time. And so then this should make it easier for you to then package software and have it continue to build over a long period of time while you're updating the pins to the underlying package scope, package sets. Okay. The other thing too is that then it also makes it easy for you to communicate your overlays to potential other downstream consumers, so other Flakes and stuff like that. By having the packages modules, you can just kind of bundle up all of your overlays and then just expose a single entry point for them to consume. And then also too, when this comes to evaluating whole systems, and so like what would be the NixOS system and upstream Nixpkgs, then this has a very similar exposure to kind of like the nixpkgs.overlays. You could have nixpkgs, or sorry, it's not nixpkgs, it would be Ekapkgs. The Ekapkgs.packagesModules equals, and then you could just list those there. And then that should work fine because the pkgs fixed point should be evaluated before the config fixed point. All right, make toDevShell's easier. So this is kind of a crazy idea that I have, at least in the current way that I'm going to explain it here. One idea would just be to have it where any derivation that gets called with make derivation now has this .toShell function on it. But how it works is that it's kind of similar to make shell, but it kind of uses the original DRV as the blueprint, and then anything that you pass it actually just gets appended in addition to what was there before. So the idea here is that I have a release build for my thing, but then when I call toDevShell, then I can opt into like a debug workflow, and also I can append certain things that are nice for my dev environment. So like the example that I have here is a Rust workflow. So on the top, you would do something where it's like, well, I got to do make shell, but make shell gives me GCC, and Cargo uses LLVM, and it makes more sense to use Clang because now I have a smaller closure size for my package. And so then now I have to do make Clang shell, and then I had to specify Cargo Rust format and Rusty. May not need to have to especially specify Rusty because I think Cargo re-exports it. But the thing here is that it's like maybe Clang here doesn't align with the LLVM version that Cargo is using. So then that could be one potential weird thing where like I actually have two different versions of LLVM getting introduced and that's awkward. And then in addition to this, it's just like, yeah, it's like you can't, it's actually very hard to know like if you wound up in the place that you intended to be. Whereas in the new workflow with the .toDevShell, effectively what you're doing is just like, in addition to what was true before, I just want this additional thing. So here I have Rust format, which is just a formatter for Rust. But everything else that was true for my package, maybe I have OpenSSL, package config, etc. also in there too. It's like, in addition to those guys, I also want just Rust format, and then I'm good. Like that's, and then maybe something like Clippy. There we go. And then we're cooking with gas. And this comes up a lot. So like, for example, with, here's like a Python example in a Flake. And so then, I would get my core packages. I'd get the Python overlay so that I have more Python package availability. And then when I'm composing these things, I just pass those to the Python packages module, and then my local one into the makeFlake, and then those would apply all the overlays at the appropriate package scopes. And so then now I have a packages and Python packages that has all the stuff that I would expect on it. And so now when I'm wanting to expose my packages and dev shells, I can just kind of select them off of that fixed point. So here the packages checks and dev shells get past a packages fixed point, and then from there I'm just able to select the things that I want. And then you can see here like Python, this is kind of nice because now you can just say like, in addition to what was true for my Python packaging, I just want a VM shell hook, and also I want the VM dir to be named with the Python version suffix, which is nice. And then too, for like Ekapkgs, effectively what this would just look like is like we have our dozen or so different ecosystem overlays, and then we have all the inputs that are enumerated. We just recombine them, and then makeFlake here would also expose the legacy packages, and so then they should all be available and for use. That's about it. Yeah, if you would like to know more about EkaCI project, it's a slow burn right now for Ekapkgs, just because I'm more or less just trying to grind away on EkaCI first before I want to do the curation. Once package curation is optimized for my time, then it would be much easier to do. I don't want to, bootstrap a thing. I didn't do a proof of concept, but like, I don't want to maintain something where it's actually very painful to do the work. What I would like for is that EkaCI essentially make it very valuable usage of my time to do the package curation. Anyway, so once that's in place, then I do feel like it'll be in a lot better place and it'll actually be usable. And I'm really excited to actually have this be kind of like out there in the wild, and then also to get people that also kind of have similar pain points that they've also had with Nixpkgs be able to kind of apply their proposals, and we all kind of benefit from just being able to iterate on the status quo. Thank you for tuning in. I guess you could comment on the YouTube video if you like. I usually watch those comments and I'll reply. Other than that, I would just recommend you getting involved with the EkaCI project. We have a Discord for chat right now. We don't really have any other chat platforms, unfortunately, outside of GitHub. And that's not really a chat platform. But yeah, other than that, just keep your ear to the ground on EkaCI, and hopefully in the future we will produce amazing and beautiful things. Have a great day.